What I'm going to show now is solids generated from revolving around the x-axis, and there are two methods for doing this. And the first method that I'm going to show you is the washer method. And the reason we call the washer method is basically it has a hole in the middle, it's two circles, and it looks like a washer that's used in building. The whole idea behind this is we have two curves, f of x and g of x, and in this case it's bounded also by a vertical line. And the idea is that you take the solid and you revolve it around the axis, and it makes this cone shape right there. And if you were to cut the end of it off, it looks like this washer right here. Now, the formula for solving this, so this is the washer method, revolved around the x-axis, and it's very similar to area in that we're going to look at it in terms of x. We will use x values on the x-axis, but we're going to base it upon the area of a circle. So each one of your functions is now squared and subtracted like this. So let's go back to the picture that I had. Let's call this one let's call this one y is equal to x, just because it's easy to use. And we'll call this one y is equal to 2x. And then we'll make this vertical line x is equal to 2. So your problems will say find the volume of the solid generated by revolving the region around the x-axis. So let's plug into this. Now, this x is equal to 2. This ends up being the b in our formula. And again, like the area problem, it's top minus bottom, or upper function minus bottom function. So top, bottom. And we will substitute this into our function next. Okay, with everything substituted in, very important to notice, you are going to square your functions before you subtract and before you integrate. It's going to go in this order: square, subtract, integrate. So make sure you square everything that's inside the parentheses. And this is what we have here. And combining our like terms, we will have 3x squared dx. And when we integrate, we end up with x cubed pi from 0 to 2. And let's substitute in now. So we have our pi. We're going to cube the 2, cube the 0, and 8 pi units cubed. Now let's talk about another method for revolving around the x-axis. Now with the shell method, instead of, if you're going around the x-axis, you want to use our variable as y. So with the washer method, we cut through the axis that we were revolving around. With the shell method, you're going to cut through the other axis, and so everything isn't going to be in terms of y this time. And instead of doing top minus bottom, like with area, we're going to do right minus left. And I changed this equation a little bit to make it a little bit easier to do. So let's substitute it. Actually, let's establish our equation first. This one is not based on the area of a circle, it is based on the circumference of a circle. And since it's in terms of y, everything is y. So the values that we put on our integral come off of the y-axis. So this is 2 pi y, f of y minus g of y dy. And this is the right function right here minus the left function on the other side. So we would substitute this in, and you're going to notice no squaring. So 2 pi y, we have f of y, so the right side is y, the left side is 1/2 y dy. Now before we can integrate, we need to subtract and distribute that y on the outside. So what we have now is 0 to 2, 2 pi y times 1/2 y dy. Okay, so now let's multiply. So we're not taking the integral yet. So we're going to multiply, and all this leaves us with is pi times y squared, because the 2 and the 1/2 cancel, and then dy. And then we will have pi times y cubed over 3, 0 to 2. And we're going to plug in the 2, so pi times 8 over 3, plug in the 0, 0, equals 8 over 3 pi units cubed. Okay, and that's how you find the volume of something revolved around the x-axis. I will be making another video of a volume revolved around the y-axis.